So yes, Dr. Futese also shared, apart from the PPT, he shared some data files which were labeled as Part 7 app. So in that, when you extract that zip folder, you're going to open from the network editor, compress open. Then you can locate to where you have saved your Part 7. Then in Part 7, you have several folders. Step 1, 2, and 3. You're going to open step 1. And then you're going to open this network file. Okay. Yes.
Then you can see their network files. So there you can go the third icons, which is showing the read open line data files. Yes. Then in the step 1 folder, 40% line TNT files. Yes. So this one show in the indicators and in the network files, you can see the some links is visualized in the red color. You can change the line names to the all. Yes. So this section visualize that the red color links is the lines which there is a public transport network. This one showing the blue color lines is the expressway. Yes, I supposed. So this is the expressway. There's no public transport route. So this lane is supposed to be open for the private vehicles. On the other hand, so the other arterial lines, so the red color line showing the public transport corridors as provided. Then, so just Samuel, could you open the parameter files?
Okay. So opening the parameter file, it's this icon with a 50. And then for this parameter file, we are going to open this ending with .tpa. Open, yes.
Okay. Yes, and the PowerPoint files which I shared with you, and I prepare the definitions of the informations which is included in the every transit line files and the transit parameter files also. So I will briefly explain about the each items which is shown in this table. Then this screen showing the user interface of the TNT files. This one show in the list of the public transport route which is available in the target area. Then the mode number, which is the later defined by the parameter files. And whether this bus route is one-way route, sometimes this is so-called the circulate or loop line. In that cases, there might be the one-way transit lines. However, this is usually cases there is a two ways. And in some countries or some cities, there are so many one-way roads. I'm not sure in your countries. But in that cases, then the two one-way routes must be defined, and the so-called the CBD to suburban route, they operate these sections. On the other hand, contrary, the suburban to CBD route, but generally the same alignment. However, in the CBD sections, there are so many one-way road is be there. So in the CBD, so the route alignment is different. slightly. In that cases, you need to develop the one-way, but two types of one-way bus routes. Little bit complicated. And the third one is the access flags. In some, I'm not sure this is usually or not. However, there is some points the only boarding sections or only alighting sections. So that if there is some specific rules about the boarding and the alightings by the sections, such kind of flag, this is no boarding points or no alighting point or interline transfer only points or some the specific regulations must be specified. And the service frequency, meaning the frequency of the service, meaning how many trips per hour. So the 12 vehicles per hour, meaning the 5 minutes intervals is provided. Then the scheduled speed. And so that if you need to insert some sections along on the network, you need to modify these sections. Then the parameter files, so that there are 1, 2, 3, 4, 5 tabs is provided. Then the number of modes, meaning number of modes available in the cities must be specified 4 to 5. For example, bus, BRT, Matatsu, or commuter railway, or some metro rail, such like this. The specifications of the mode must be specified. And the transit speed adjustment factors needs to be impiled to the transport parameter files. I will explain detail in later. And the third one, this one show in the route share methodology in the transit assignment method. For example, if there in some OD pair from zone A to zone B, according to the transit network, there are 4 to 5 pathways which can be accessible from the zone A to zone B. In that cases, the share of the route for each routes must be specified in the following formula using the generalized cost of the route and the minimum generalized cost between the zone A to zone B. So the methodology which formula is better is up to the result of the calibrations. So in that cases, you need to correct the daily ridership by bus route, not only the frequency and the vehicle types which is used, and sometimes fare is also must be. Then the second term, and this is usual same with the usual transit highway parameter files, which zones must be specified as a zone centroid of the network, zone 1 to zone 70. So the which zone, node 0, 1, 2, 5 is considered as a zone 1. Zone 2 is 219, zone 3 is 315. And for the transit assignment, the assignment methodology is by the incremental assignment because the transit assignment is very complicated. So the equilibrium assignment is not suitable for the because for this due to the limitations of the computers. Then the option parameters in the maximum transfer meanings are, for example, there are so many complicated transit network is specified. So that you can go from anywhere to anywhere by you transferring transferring their bus routes. However, if you allow the so many transfer, so the available pathways will be more and more. So the calculations of the transit assignment will be more complicated and complicated. So usually the three transfer or 4 to 8 transfers is limited as the maximum number of transfer, which is considered as the route search methodologies. And the second one is a path reject limit. Is there, as I said, then according to the transit network, then you can choose the so many patterns of the trips. However, then the some trip patterns, which is much higher than the minimum generalized, so-called the minimum generalized cost path. Such kind of route should be excluded from the route search method. For example, you can go from Rimuru to CBD. Yes, if you can can ride one bus or 2 buses. You have some choices. However, in some cases, you can go to the CBD via so-called Rimuru to Ruiru and go to the CBD. On the Rimuru, Naivasha, CBD. Such kind of route is theoretically possible. However, such kind of pathway should be excluded because it's not logical. Theoretically okay, however, logically no. So some trip patterns with more generalized cost multiplying these specified values of the minimum generalized cost can be excluded. Then theoretically speaking, 110% is the so-called standard values for choosing the route searches. And the use of velocity, meaning, according to the highway assignment, you can see some links and the peak hour velocity and our average travel speeds and the peak hour travel speeds can be obtained. In that cases, for some route search methodologies, peak velocity or average velocity can be selected. Then the detailed sessions will be explained later. And the first one is the mode specifications. According to for each mode, which is specified in this transit parameter files, zone mode 1 to 4 or 5, then the fare level, and the specifications by the modes. For example, then the passenger capacity per vehicles, yes, this is for the large buses, which the passenger capacities per vehicles is 80. And the minimum frequency per hours should be 1. And the maximum frequency is up to the city's situation. However, currently 10 is specified. If for example, the 15 trips is specified, say, I think that there will cause some error and you can't assign the conduct a transit assignment. And the PCU equivalent meaning so one vehicles can be converted in the passenger car unit basis. Then the minimum travel speed and the maximum travel speed. And you can see that these links, this standard travel speed can be defined in this transit network files if this travel speed is slower than the minimum speed or faster than the maximum travel speed, you can the transit assignment will be rejected. Then the last one is more complicated. So the generalized cost coefficient, meaning the according to the travel times and answer the ここか。travel time values, meaning how many minutes per cost. And the every generalized cost and to the travel times and the travel cost will be generated. However, it is more complicated issues and the walking times, 1 minute of walking times and onboarding times and waiting times must be different. So then if you have the specific figure and the 1 minute walking times is equal how many minutes onboarding times. So the such kind of the you can modify this coefficient of the every times which will be converted to the generalized cost.